All right. So now what I want to talk about are the real models that we encounter in social and behavioral sciences. And in order for me to really demonstrate what I mean by real models, I want to walk through some data with you. So what I'm going to do is I'm going to create data similar to what I did before. I created an I created an X variable, which is a random normal variable. Then I created a moderator, or a mediator. I create a mediator, and that mediator is a combination of my antecedent X as well as some noise. And then I'm going to create a temporary Y variable, which is a combination of both the mediator as well as an interaction between my predictor, my primary predictor X, and my mediator. Notice what I'm doing is I'm building in complexity in the model by throwing in moderation. Now what I do is I compute a Y variable where I add random error or noise to my temporary Y variable. And then finally, that I'm going to create another Y variable, Y2, that has error that is consistent with the mean of YT and the standard deviation of YT. And what I want to do with this data set is I'm going to talk a little bit about the results when I do a simple Sobel test with bootstrapping and why you really need to pay attention to this. The data set here and the previous data set will be available for everybody to use during class this week. So what I do is I created this data set already and I ran a simple Sobel test with bootstrapping. So remember, what we have is we have these models where I have them in order of Barron and Kenny. Barron and Kenny says first test C. Notice that C is non-significant. Then I go to B and C prime. Well, I have the B parameter is significant, but C prime is not significant. And then finally, I test the A parameter, which is significant. So if you go to my little simple output, you'll notice that the path C is significant. Path C is non-significant. Path A and path B are both significant, and path C prime is not significant. And finally, that there's evidence of suppression. Now, I'm not going to cover suppression right now because we'll talk about that in class. But I did post an article on additional resources that I'm going to cover in the next video by Dave McKinnon that you really ought to read so that you understand the complexity, because this is what we're going to be working on in class this week. We're going to be working on these complex models. So if you can see here, I have the mean results for all of my parameters, including my indirect effect, which is 0.64 with a standard error of 0.21. And I plotted this effect, and you'll see that it is significantly different from 0 because my 95% confidence intervals do not overlap with 0. So I have a significant effect. I have a significant effect, though, in spite of the fact that I have no direct effect between X and Y. And we're going to talk about this at length, and you are going to unearth what this whole testing of mediation is using the Barron and Kenny method along with some more contemporary methods for testing mediation. The complexity in our models are such that, let me see if I can go to my little drawing diagram. The complexity in our models is such that now what we really have is we have a moderation effect between M. So M is both an ME and an MO. It's a mediator and a moderator because it stands in between X and Y exclusively, but there's also a moderation effect. And why do I know there's a moderation effect? Because I modeled my Y variable. This variable right here is a function of M times X. So therefore, what we should be seeing is a moderation effect, but I never tested one. So if I go back here and I test my moderation effect, if I just did summary of lm y tilde x star m data equals dat 6a, you'll see that I do indeed have a moderation effect that has not been included in my model. So therefore, what I'm demonstrating here is, one, I've created data that has a moderation effect, and I excluded it from the model. When you exclude it from the model, all sorts of funny things take place, where we still have a non-significant effect for x, but the relationship between x and y is contingent on m. So therefore, even though we do not have a significant main effect, that significant main effect, remember when we are thinking about the relationships in simple slopes and simple intercepts, if there's not a main effect for the primary predictor, that means that the primary slope is not significantly different from 0. But the slope depends upon m. So therefore, when we are accounting for y, we need to include both x and m, because x serves as a moderator, or m serves as a moderator for the slope, or the line of best fit between x and y. So now what we've done is we've created a complex model, but we've only tested it with a mediation effect. By doing this last model that I just ran, I tested a moderation effect. So what we need to do is we need to test both mediation and moderation, and there are ways in which we can test both of them simultaneously. And that's what we're going to work on this week, and I want everyone to make sure that you come prepared with the tools necessary in order to test these. So stay tuned for the final video where I talk about the additional resources, because these are the things that you're going to need for this week.